All right, so today's lesson is lesson 5 on our quadratics unit. And we're going to do something called factoring x squared plus bx plus c. Okay, so your learning target today is you're going to learn how to factor quadratic equations in this form, x squared plus bx plus c, and then you're going to have a worksheet to go along with it. Just as a heads up with this, you've actually already done factoring. You've done it with algebra tiles. So this particular lesson is going to give you another strategy for factoring quadratics in which you will not have to use algebra tiles, just as a heads up. Okay, so you're going to learn how to do it without relying on drawing squares and rectangles to figure it all out. Okay, all right. First things first. We've got two things on our definitions list today. One of them, first of all, is something called a quadratic equation. So when you are dealing with expressions or equations and it has this exponent of 2, that's called a quadratic equation. And it's written, typically we write it in the form of where the x's are decreasing in terms of their exponent. So x squared, this is just x to that imaginary first power, and then this last one is a c. So in this case, x squared and this x are variables, and b, oops, I don't know if that color is going to show up very well. B and c are numbers. Okay, so b is the coefficient to the x term, and then c is just a plain constant. Okay, so when you talk about or see the words, hey, factor this quadratic, in your head, you should be thinking of the fact that you've got this x squared term. Now, here are the steps for factoring quadratics. The first thing that you're going to do is you're going to find two integers that multiply to make c. So find two numbers that multiply to make whatever c is, that add up to whatever b is. So take a moment to write that down. Find two integers that multiply to make c and add to b. Then once you figure out those two numbers, you're simply going to write that expression or that answer, those factors, inside two sets of parentheses. Okay, x plus whatever one of the numbers is and x plus the other number. Okay, so you're going to go from what this is called expanded form into factored form. When you have your information from this slide written down, if you could click the raise hand button so I know you're ready for me to move on, that would be great. All right, again, after you get this information on this slide copied, if you click the little raise hand button so I know you're ready, that would be awesome. All right, most of us are ready, so I'm going to move on to our first example. So if you take a look at it, the directions are going to be to factor. So you're going to factor the expression x squared plus 11x plus 24. So go ahead and write that on your paper. And then you guys did diamond problems last year, I'm pretty sure. So we're going to revisit diamond problems, which is what we use to actually factor quadratic equations. Yes. Yep, the one from last Thursday. You got it. And what we're going to do is we're going to take that idea and show how to factor expressions now with variables and not just doing it with the numbers in the top and the bottom. All right, so again, we're going to factor it. So like we talked about last week, we're going to look for two numbers that multiply to make the number 24 that add up to 11. Now, we did talk last week that if we struggle with thinking about the factor pairs that go with it, the first thing that I'm going to recognize is I need two numbers that multiply to make to a positive number. And I need two numbers that add up to a positive. Okay, so some number plus another number is going to equal a positive number. That's key because sometimes we need to recognize that we're going to need two negative numbers in here, or we might need one of each. So again, then you think of the factor pairs. If you are just struggling for some reason with the factor pairs of 24, remember you can simply start with a nice organized list. When I do it, I always start with the number 1 and I just go straight down my list of factor pairs. 1 and 24 does not add up to 11. 2 and 12, that adds up to 14. 3 and 8, that adds up to 11. So I know that my two factors are going to be 3 and 8. Now, this is what we did last on Friday, where we looked for the two numbers that multiplied to make the top that added to the bottom. What we didn't do is use that idea in terms of writing quadratic equations. So now what happens, once you know that you've got a positive 3 and a positive 8, each, you're going to set up two sets of parentheses, and they're both going to start with x because you've got a plain x squared here. And then all you're going to do is plug plus 3 into one of them and plus 8 into the other one. So it's going to look like this. The quantity of x plus 3 times the quantity of x plus 8. When you have everything from this slide written down, click the raise hand button so I know that you are ready to move on. Okay, I'm going to give you just 30 more seconds to get this written down, and then we will move on to our next example. So again, the big idea here to look for is what two numbers multiply to make this 24. You know what I didn't mention? I know what we had it in the definitions on the first slide, but remember the number that's in the space as C, the plain number, is always what ends up going here in the top with what you multiply to make. And then the coefficient that's with the x term is what they add up to. Okay, so keep that in mind as well. All right, let's move on to our second example. Go ahead and unclick your raise hands. So here's our second example, the same thing as the previous one. We're going to factor the expression m squared minus 22m plus 21. So go ahead and get that written down and then draw your diamond problem as well. And then just as a reminder, when b is negative, so this term right here is negative, okay, and the last term is positive, we're going to need two negative numbers. So when we figure out what our two factors are, it's going to be a negative something here and a negative something here, because we know a negative times a negative makes a positive, and a negative plus a negative keeps it a negative. So again, we need the two numbers that multiply to make this positive 21, and we need two numbers for that. And again, if you need to think of the factor pairs, I've got 1 and 21. I've got, what else do I have? 3 and 7. Oops, and we need them all to be negative. I forgot, my apologies. So those are the only two factor pairs that multiply to make positive 21. And we need this top one as our factor pairs, because that's the one that adds up to negative 22. So again, once you have that information filled in the diamond problem, then again, since there's a plain m squared here, there's nothing in front. You're simply going to set up two sets of parentheses. You're going to set up, I forgot I was going to show you how you can check your answer. You're going to set up two sets of parentheses. Notice how they each get an m, and then one of them gets the -1 and the other one gets the minus 21. Now, if you think back to what we did a couple of weeks ago where we did the double distributing in terms of expanding expressions, I think we did this actually in the last unit, maybe? Towards the last unit, actually at the beginning of the, I don't know, it doesn't matter. But remember when we talked about double distributing, we did m times m to make m squared, and then we did m times negative 21 to give us negative 21m, and then we did negative 1 times m, and then we did negative 1 times negative 21. We did this a couple weeks ago, maybe 2-3 weeks ago. And then we simplified our terms, right? So this is m squared minus 22m plus 21. Now, you don't have to do this, but this is certainly a way to check to make sure that your factored form is correct and would end up turning into your expanded form once you have it. Okay, so that's just a way of showing you how you can check your answers. Kind of like when we learned how to solve equations last year and reviewed in the fall, you can check your answers by taking your answer and plugging it back into the equation. It's kind of the same idea here. All right, click the little raise hand when you're ready to move on. Okay, 30 more seconds, then we're going to move on. All right. Now, one thing that I should point out, folks, is that if for some reason you get here and you're like, there just is not a factor pair that's going to work, I will tell you there are some quadratic expressions that are not factorable, but I really would encourage you to write down this list of factors just to make sure that you have everything that you need for it. Okay, like you've double checked to make sure that you've exhausted all possibilities. All right, here's example number 3. Go ahead and unclick your raise hand button so we know. All right, so example number 3, we're going to factor y squared plus 13y minus 48. First question, what number is going to go up here in the top of our diamond? Thank you, Itzel and Jessica. Correct. And how about I get someone from Emma M., Lily, Ian, Chloe, or Eric? What number is going to appear down here in the lower part of the diamond? Yes. Yes, yes, yes. Thank you. Now, here's the thing again. If multiplication and factor pairs are not your strong suit, okay, then you're going to list a factor pair here. Now, one thing to remember, or hopefully it maybe that you've already noticed, I know I need 2 numbers that give me a negative product that add up to a positive number. The only way that that is going to work is if one of our numbers is positive and one of our numbers is negative. Okay, again, when C, that's that plain number by itself, is negative, we need 1 positive and 1 negative to the point where our sum is going to equal 13. So again, I will just say, if for some reason, like factor pairs are just not your thing, I know I need a positive and a negative, so I'm going to check positive 1 and negative 48. Well, there's no way that's going to add up to positive 13. And even if I switch it to negative and positive, this sum is going to turn into 47 for the second one, right? So I know it's not either of these. Then I go to 2 and negative 24. I add those together. That's going to give me negative 22. And if I flip it around, this is going to give me positive 22. So that's not going to work either. And by the way, again, if these don't like work out in your head, just grab a calculator and start with the number 48 and just do divide by 2, see what comes up, divide by 3, see what comes up, divide by 4, see what comes up. If it's ever a decimal, then you know you're not going to use that one because we typically only look for whole numbers here. in each of these sides. Okay, so I'm going to do the same thing. I'm going to do, I know also that 3 times 16 gives me negative 48. Oh, if I add these together, this gives me negative 13, but I need positive 13. So if I switch it around, aha, there's my factor pair. So I'm going to put negative 3, and then I'm going to put 16. Now, just as a heads up, I could have put 16 here on the left side, and I could have put negative 3 here on the right. Remember, multiplication and addition are commutative, so you can switch the order and you're still going to get the same answer. So then again, once you have those factor pairs, that factor pair, then you're going to take those numbers and plug them into the parentheses. So you're just going to do y minus 3 and y plus 16. Again, you could switch them around because it's the commutative property allows that to happen. But it doesn't make it wrong if you do y plus 16 and then y minus 3. So those are the 3 examples that I have for you. Before I move on to the closure, what questions do you have about this? Clarifying questions. Can you explain again why? What do I need to do if? Any of those kinds of questions? All right. So on your paper, here is your closure. Oh, Sam, go ahead. I don't recall ever seeing it happen, and the main reason why is, first of all, if C is negative, there's no way that will happen, right? Because you need one positive and one negative. There will be times where these 2 numbers on the left and right will be the exact same number, right? But like a positive 6 and a positive 6 here and a negative 6 and a negative 6 would give us 2 completely different scenarios, right? So without having a specific example off the top of my head right now, I would say no, there will be only one factor pair that will work, or none, okay? So again, if you can't find that factor pair, it might just be none. But I would make sure that you write this list of possibilities before we decide none. All right, so here is your closure for today. How do you know when you will have the following answers for the factored form? So how do you know when you're going to have both pluses inside your parentheses? How do you know when you might have one addition, one subtraction? And how do you know when you're going to have subtraction in both of them? Take a moment and write that down, please. How do we know? Again, how do you know when both are inside 2 sets of parentheses, or both have addition, both have subtraction, or it's one of each? And if you look back to examples 2 and 3, those should be pretty good indicators for you as to what you're looking for. All right, when you have that, you can flip over to Schoology. Whoops, go away. All right, flip over to Schoology. You're gonna, you might need to refresh your screen. You're gonna look for worksheet number 5. And you can either print it out or write down the problems in your math notebook like we've been doing. Take a picture and put that in for lesson 5 on your DUR. You guys, just a heads up, when you post links in your DUR, if you could actually grab the link from the Google Doc and post it on there, that would be great. And then also, if you take screenshots of your worksheet in Schoology, I need you to make sure that you're including all of the problems on that worksheet, please. Some of you are kind of making a not so good habit of just doing a part of the worksheet, but I need to see the whole thing. Okay, so just as a heads up with that. And then again, at some point, you might want to check your grade to make sure that, first of all, I have everything accurate, but then secondly, make sure that you are getting your missings and incompletes taken care of.